Okay, this is our last section, and we're going to look at transformations of trigonometric functions, basically working with sine and cosine and graphing and what happens to it. So, if we look at a graph, and we're going up to from negative 4 pi to positive 4 pi. So this is pi, 2 pi, 3 pi, and 4 pi. And we have negative pi, negative 2 pi, negative 3 pi, negative 4 pi. We have 1, 2, 3, negative 1, negative 2, negative 3. Now, we basically, when we're doing graphing, we basically work with the quadrantal angles. So that would be pi over 2, 3 pi over 2, and so on. So, in general, cosine, if we think of it at 0, cosine is 1. At pi over 2, it's 0. At pi, it's negative 1. Then at 3 pi over 2, it's 0. At 2 pi, it's 1. And then it just repeats itself, because cosine and sine both are cyclic. Oops. So it looks something like this. Now, if we take that function and multiply it by 3, that means instead of starting at 1, we're starting at 3. We're still going to 0. We're going down to negative 3. So we're changing what we call the amplitude. The amplitude is the positive distance from the x factor to the highest point. So that's what happens when we multiply by 3. The graph would look like that. So the range of cosine of x, the range is from negative 1 to 1. And for cosine of 3x, or 3 cosine of x, the range is negative 3 to 3. The amplitude of cosine is 1. The amplitude of 3 cosine is 3. And basically we talk about, this text talks about the amplitude as the difference between the high point and the low point. So if we do 3 minus a negative 3, we get 6, and then we divide by 2 to get the 3. 1 minus a negative 1 is 2. Divided by 2, we get our amplitude of 1. Now we're going to do the same thing with sine, except it's now a negative 3. So if you remember from our transformations of regular graphs, the negative tells us we flip over the x-axis. So here's pi, 2 pi, 3 pi, 4 pi. And then negative pi, negative 2 pi, negative 3 pi, negative 4 pi. And we're going to go as high as 3, as low as negative 3, and the general graph is 1, negative 1 to 1. So sine, if you look at the unit circle, at 0, the y-coordinate is 0. At 1, at pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's back to 0. And then it repeats itself for the next cycle. So sine looks something like this. Now, with the negative 3, we're flipping over the x-axis, so we have a reflection, which means instead of going up first, we're going down first. So we have negative 3, 0, 3, 0. Negative 3, 0, 3, 0. Three, 0, negative 3, 0, 3, 0, negative 3, 0. So it looks something like this. Now the range for sine of x, the range is the same as it is for cosine, from negative 1 to 1. For negative 3 sine of x, the range is the same as it is for the 3 cosine of x, which is from negative 3 to 3. Now, the amplitude, well, it's 3 minus negative 3, which is 6, divided by 2, is 3. That would be the amplitude for the negative 3 sine x. Then 1 minus a negative 1 equals 2, divided by 2 equals 1. That would be the range for sine of x, or the amplitude for sine of x. Now we want to sketch the graph of cosine of x and 2 plus 0.3 cosine of x on the same interval. So we're going to do it on the same graph. Okay, so we have pi, 2 pi, 3 pi, 4 pi. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. We have 1, negative 1, and 1. So cosine starts at 1, goes down, then back up. So it looks something like that. Now, what's going to happen with this? We have the 2, so we're going to add 2 to everything. But we also have this 0.3, which means the amplitude is going to decrease. So that's going to really affect what we're doing. So if we do up to 2 and up to 3, but it's really not going up to 2 and up to 3. We're only going a 0.3. So the high is going to be at 2.3. The low is going to be at 1.7. So we're going to start at 2.3, come to 2, down to 1.7, back to 2, back to 2.3, back to 2, down to 1.7, back to 2, back to 2.3. So we have something like this. Okay. And then looking at our range of the new function, the range of the new function is from 1.7 to 2.3. And then the amplitude is 2.3 minus 1.7, which is 0.6 over 2, which is 0.3. Now we're going to change it a little more. We're going to do 3 plus cosine x, and then cosine of 2x on the same. So we have 3 plus x, which means instead of going up to 1, we're going up to 3, but we're starting. That's going to be the midline, so we're really going from 2 to 4. So we start at 4, down to 3, down to 2, up to 3, back to 4, and then do it again. We have something to look like this. Now, what's going to happen with that cosine of 2x? It's still going to be the shape of the cosine graph. And we're going to have the range from -1 to 1, because that's what it is for the general graph. But now we're doing a 2x instead of x. So cosine at 0 is still 1. Cosine at pi over 2 is going to be the same thing as cosine at pi, which is a negative 1. Cosine of pi is the same thing as it is at 2 pi. Cosine of 3 pi over 2 is the same as 3 pi. Cosine of 2 pi is the same as 4 pi. We have something like this. So it's kind of squished together. It's like you've taken a spread out spring and you're pushing it together a little bit. The range is still between -1 and 1 because we haven't changed anything. The amplitude is 1 minus a -1 gives us 2. Divided by 2 is 1. Now the period, we've cut the period in half. So the general period is 2 pi. We have a coefficient of the x as 2. So that means our new period is pi. So now we want to do the 7 sine of 2 pi x. But this is going to be a little different because we're now going from -3 to 3. So it's 0. Okay, we're going up to 7, down to -7. So it's 0, it's 0. At 1, 2 pi times 1 is 2 pi. So it's 0. At 2, 2 pi times 2 is 4 pi, so it's 0. At 3, 2 pi times 3 is 6 pi, so it's 0. So that means we have to go up halfway in between 0 and 1, down in between 1 and 2, and up in between 2 and 3. And then it's going to go the opposite way. So down between 0 and -1 and 0, up between -2 and -1, and down between -3 and -2. So we have something that looks like this. So the range is -7 to 7. Amplitude is the 7 minus a -7, which is 14 over 2, which is 7. The period now is a general period of 2 pi divided by the coefficient of the x, which is 2 pi, which equals 1. Okay, now we have x and x minus pi over 3. Now this is going to be another interesting one because we're making another change. But if you remember from when we did transformations of regular graphs, this inside the parentheses means we are adjusting or we are changing horizontally. We're making a horizontal shift. So we're going from 1 to negative 1, going up to 4 pi. So that's pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So we start at 1, go to 0, down to negative 1, back to 0, back to 1, 0, negative 1, 0, 1. And then the other way. So we look something like this. So what's happening now is we're subtracting pi over 3 from our angle. So 0 minus pi over 3 says we're getting the cosine of negative pi over 3, which would be square root of 3 over 2. That's what we're going to have here. But essentially what we're doing, we're shifting it to the right pi over 3. So pi over 3 is about here, 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 and so on. Just every point is shifted pi over 3 to the right. So it's going to look something like this. Now the range, still the negative 1 to 1 because we didn't affect that any. The amplitude is the 1 minus negative 1. Gives us 2 over 2, gives us 1. And the period, we're not affecting the x, so the period is still 2 pi. And then we're asked by what fraction of a period of cosine of x has the graph been shifted to the right. And it's been shifted pi over 3 to the right. Okay, these are supposed to be pi over 3 instead of x over 3. So we want to sketch the graphs of 5 sine of x over 2 and 5 sine of x over 2 minus pi over 3. So we have 1/2 is our coefficient of x, that means that our period is going to be 2 pi divided by 1/2. That's actually down here. We have 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. So that means every 4 pi we repeat it. And we're looking at sine. So we have, our graph looks something like this. Now we want to subtract pi over 3, which means we're moving it not only a factor of pi over 3, but we're working with it with our 1/2 as well. So actually moving it a factor of pi over 3 divided by 1/2, which is pi over 3 times 2, which is 2 pi over 3. So we're moving 2 pi over 3, 2/3 pi. So it's going to look something like that. So I'll range the -5 to 5. The amplitude, so 5 minus -5 gives us 10 divided by 2 is 5. And we already came up with the period and the shift. Now, we're going to see how this is used. Here we have the average monthly temperature in Chicago for the 5 years ending in January 2011. So this is 06, 7, 8, 9, 10, 11. And the 12 data points for each year have been joined by line segments. The graph appears somewhat periodic. We want to find a function of the form a cosine bx plus c plus d. The model's the temperature in Chicago, where x is the measured in years, thus x equals 2010.5, would correspond to halfway through the year 2010. Well, here's how it works. A, which is the amplitude, is the max minus the min over 2. And the max appears to be about 75. The min is about 20 over 2 is 55 over 2, which is 27.5. D is the max plus the min over 2, which would be 75 plus 20 over 2, which is 95 over 2, or 47.5. B is 2 pi over the period. Well, in this case, the period is 1 because it repeats every 1 year. period equals 1. Because it repeats every year. This would be 2 pi over 1 equals 2 pi. Now, the problem is trying to figure out what C is. So to get C, it's C equals cosine of 2 pi x plus C equals -1. That's how you come up with C. Except we're going to get rid of this x because it's not going to affect it. And this is because the minimum occurs at the beginning of the year. So if we solve this, cosine of 2 pi plus C equals -1. So 2 pi plus C equals cosine inverse of -1. So 2 pi plus C equals pi, and C equals -pi, because we subtract 2 pi from both sides. So we have 27.5 cosine of 2 pi x minus a -pi plus 47.5. This becomes 27.5 cosine of 2 pi x plus pi plus 47.5. So that would be the function that would graph this graph. And that's our last set of work.